Eric Burgess here, and we have been given the following question. Find the 95% confidence interval for the variance and standard deviation of the ages of seniors at Oak Park College if a sample of 22 students has a standard deviation of 2.5 years. Assume the variable is normally distributed. All right, so we've been asked to find a confidence interval, but for a variance and a standard deviation. So this is one of those formulas I don't have off the top of my head, but this would clue you in on which one to go look for. And I've already written it here. So whenever you see variance, standard deviation, you know you're going to need that one formula with the weird chi-squared thing. Okay, that's how I kind of remember it. I'm like variance, standard deviation, weird chi-square thing. Also keep in mind that chi-squared shades area to the right always. So it's a bit different than you might be used to. So we want the chi-squared on the right side and on the left side for the corresponding formula. But anyways, this is the formula we need. We know we need it because of the thing I just explained. So let's go ahead. Let's get all the values out of this problem. And then we will dive into actually plugging it all in. All right, so first off, we're told we want a 95% confidence interval. That immediately tells us that alpha is going to be equal to 0.05. And because we're going to have half of it below the standard deviation, well, in this case, it's the variance, and half of it above, we're going to need to split our alpha in half. So alpha split in half divided by 2 is 0.025. And again, I always recommend just check it on your calculator. I've seen mental mistakes here way too often for this kind of a thing. Just type in 0.05 and divide it by 2 and just make sure that you've done it right. I see sometimes people accidentally write 2.5 because you're thinking in percents and it screws up the process. So just be careful. Make sure you're in decimal. All right, so that's our first one. And they want variance, standard deviation. Note that the formula here is for variance. You just take the square root of everything to get the standard deviation. And okay, the sample is 22, so that's important. N is 22. That means our degree of freedom is 1 minus that, so that's 21. And they have a standard deviation of 2.5 years. Now this standard deviation is of course a sample standard deviation. First, we know this because we're trying to estimate the true population variance and standard deviation. Also, this 2.5 years is connected to these 22 students. That's where we got it from. So it's connected to a sample. That's another way we know that it is a sample, not a population. All right, so we've got all the numbers out. We still need to find this chi right, chi left. So the chi right, chi left is going to correspond with a value of 0.025. And if we look at this, okay, let me draw out a distribution because I think it's much easier to see visually. So there's going to be one on the right and there's going to be one on the left. This shades up to 0.025 in each side. So there's a tail up here with 0.025 on it. And there's a tail down here with 0.025 on it. And the distributions always shade right. So when you look up 0.025 in the chi-squared table, it's actually going to be the value that goes here. So you're going to get this one, and this one is on the right. So this is chi right. To get chi left, chi squared, this is a chi squared left, we have to do 1 minus this. And so 1 minus 0.025 is going to give us 0.975. And when in doubt, type it out, right? There you go. A good acronym. Not even, well, that's not an acronym. You know it, a good rhyme. So just verify. Don't make any silly mistakes over goofy mental calculations. And so we say, okay, so in order to find the chi left, we need to look up this one because this is the area that's going to go. There's going to be 0.975 of this distribution going this way. And to find the chi right, we just look up the alpha value that we have. The chi-squared distribution is not symmetric. So in all the other problems that we've been doing, Z and T, we've had the luxury of the distribution being symmetric. But chi-squared distributions are skewed. And because of that, we have to find them independently. That's why these are labeled to be specifically different. So all right, let's look this up. So 0.025, 0.975, and our degree of freedom is 21. So go to your chi-squared table. Let's find our degree of freedom first. So that's 21. So we don't actually have our degree of freedom on here, and we want to be conservative. So notice that there's no 21 on my chart. You might actually have a 21, but I don't have one. And so what I'm going to have to do is I'm going to have to be conservative and go with a smaller number. Smaller numbers are actually worse in this case. And that's just being conservative. We don't want to make our data look more accurate like it is. So if the degree of freedom was higher, that would imply that we had a bigger sample size, but that's not really the case. And so we go with a lower degree of freedom. And we look up, so we're looking for 0.975, and we're also looking for 0.025. So when we look these up, we're going to have this one, and we keep going, and we're going to have this one. So we're going to have these as our chi values. So for the 0.025, we got 34.17. And so our chi right is 34.17. And our chi left is 0.959. So 0.959. Now, normally they don't draw the picture. I just think the picture is helpful. So now we have everything to plug it in. So our n was 22. So we have 22 minus 1 times the standard deviation squared. That's 2.5 squared, or you could just call it the variance, divided by chi right, 34.17. And then there's the variance, and then we have the same thing, 22 minus 1 times 2.5 squared, but this time it's divided by a smaller number. I put point. It should just be 9.59, right? Yeah, 9.59. So 9.59. So we're going to do this, and let's just do it. So it's going to be 21, right? Because that's 22 minus 1 times 2.5 squared. We hit enter. We get this. And then we're going to divide that answer. So the answer is the last thing the calculator had, by 34.17. Enter. And we get the value 3.84. And then we have our variance in the middle. And then for this side, that's again 22 minus 1. I don't know why I typed that. Times 2.5 squared. We get this value, again, same number, except for now we're going to divide it by 9.59. And we get 13.69 if we round to two places. Now, to get the standard deviation, we just take the square root of each of these. So the square root, the standard deviation is going to be, well, we take second square root, 3.84. And we get 1.96. It's kind of a beautiful result because of z-scores. And now we're going to hit the square root of 13.69. And we get 3.7. And these are our answers. Now, you could write sentences for each of these. If your professor wants it, you should definitely do it. So we would say that so what are we looking for first? We're looking for the ages of seniors at Oak College Park. So we would say that the true variance of the ages of seniors at Oak Park College is between 3.84 and 13.69 years. And the true standard deviation of seniors, the age of seniors at Oak Park College, is between 1.96 and 3.7. It's quite a bit of writing, and most professors I've worked with have been fine with this, but maybe they want to see the word years. I would write in years. So this is in years, this is in years, that's in years, and this is in years. just to sort of show that you're not just writing down like numbers according to a procedure. You know that this is describing the spread, the population spread. We know that the standard deviations between these numbers, so it sort of tells us how spread out it was. Like if this was 1.96 and like 45 years on the other side, that'd be really, really spread out. And we'd know that that's like important. That's maybe the way we sampled something went wrong somewhere. If they were all seniors, varying in 45 years of age for a single standard deviation is really big. So anyways, that's just like, you want to show that you have some insight onto what the symbols and the numbers mean. But that's all you got to do. If you have any questions about this, let me know, subscribe, and we will catch you in the next problem.